Hello everyone! Welcome to a part of my channel that is dedicated to interviews with experts from research and development and innovation. My name is Lisa and here we talk about everything related to innovations, breakthroughs, co-creation and collaboration, how to manage collaborative projects, how to increase the chances of making a breakthrough, how to foster innovation, and many others. In this video, I'm talking to Tomáš Zedníček. Tomáš is a founder of the European Passive Components Institute. He's been working in the area of passive components for more than 30 years. Tomáš graduated from the Technical University of Brno, which is in Czech Republic. He has a PhD in tantalum capacitors and he spent more than 20 years working with tantalum capacitor manufacturer. Apart from that, Tomáš has more than 60 technical papers and 1 international patent. I had a chance to meet Tomáš during one of the first projects with the innovation consulting company, and I really enjoyed working with him and his team from Technical University of Brno. And I'm really happy to have this interview on my channel. We discussed so many different topics, starting from commercialization of university research, his initiatives for the passive components area and science in general, to how AI influences knowledge-based websites. It was a very interesting discussion and I hope you will enjoy it as much as I did. Hello Tom. I'm so glad that you joined me today. I'm so happy to see you today and thank you so much for accepting my invitation to talk.
You are welcome, Lisa. It's always a pleasure to communicate with you.
We haven't seen each other for a while, but yeah, I'm really happy to see you again. And we will talk about a lot of different things today. I'm really excited, and I'm really excited to hear your opinion about all the different questions that I prepared for you. But to start our conversation, I would like to talk to you about your background and your experience, just to give an overview to the audience about what you do.
Okay, thank you, Lisa, for your invitation. Of course, about myself. I'm dedicated to passive components from the beginning of my study, and I studied electrotechnology in Brno, Technical University of Brno. And I was always linked to passive components, as mentioned, due to my location, as I'm location in Landskrona, which is relatively a small town in east-north part of Czech Republic. But here has been passive component industry since 1944, so long tradition. And even my father, he worked in a reliability lab for capacitors. So I in fact continue with the tradition of the family. So I studied electrotechnology and already focused on capacitors at that time. At that time, here in Landskrona was a big company that was called Tesla. It's no relation to Elon Musk. It used to be already for a long time. And Tesla was a big company in the former socialist Czechoslovakia at that time, supplying everything about electronics. And electronic component division on passive components had a headquarters in Landskrona. That was a big plant exported to all former socialist countries. But after revolution, which was 1989, then the Tesla had quite serious economic troubles because the product were not qualified to Western standards, so they cannot enter the Western market. And on the other hand, the complete East Bloc collapsed. So they had no way to go. But fortunately, there were some following companies that picked some parts of Tesla and continue in the tradition. And one of the company was AVX, which is a American company part of Kyocera, that picked the production of tantalum capacitors. So immediately after university, I started with company AVX on tantalum capacitors, And as I wanted to learn more, I continued externally with the university to complete PhD, and they specially tuned the study for tantalum capacitors. So I have PhD in tantalum capacitors.
Great, thank you so much. Yeah, it's very interesting. It's like your location kind of defined your future job. And right now, you are the founder, the president of the European Passive Components Institute. Could you please tell us more about your organization? What is it focused on? And how was it born? Like, why did you decide to set up this company?
I was working for AVX for more than 21 years on various positions from quality failure analysis. But last 15 years in the company, I was working on position of worldwide technical marketing manager, traveling around the world, visiting customers in different fields of electronics, from consumers through automotive, medical, aerospace, etc. So complete coverage, and also all continents. So I was traveling a lot, and after 15 years of continuous traveling, 50% of your time, I needed a change. So it was too much for me. So I decided end of 2014 to leave the company, and based on my contacts and the close work with the industry, I didn't want to lose it. So I was thinking what to do, and I start to collect news in the industry to stay in touch, and trying to continue with my collaboration also with ESA, European Space Agency. So I collected the news, and I linked it with some knowledge that I have, and then I told myself, when I'm doing this, why not to share with others? So I start to put everything on the website, and with time, suddenly I found that this website became the global biggest blog on passive components. So that's why how this European Passive Component Institute started and expanded further.
What is it now? Like, what do you do now at this institution?
There are now more activities, but everything is related to passive components. Since 2017, I start to organize biannual conferences on passive components. This was one thing that I was missing a long time. For many years, I was visiting CARTS conferences that had a long tradition from 1970, but ended in 2014 out of economy scale. Because it was great from 90s, where we see really discussion within the complete supply chain. So in the conferences, we had people like Nokia, Motorola, IBM, and everyone, because this was the main communication challenge. And we discuss all the topic related to passive components there on this forum. But with the rise of internet, such discussions were more online, and there were lower interest from end users to really engage and spend time and money to send engineers to such conferences. So conferences in around 90, there were easily 200, 250 people just on passive components. And then with rise of interest, it shrink like to 80. And when it's organized in hotels, etc., it become too expensive. So it went out of economy and terminated in 2014. But my friends, my colleagues say, oh, it was a good forum that we finally meet and we could discuss specifically about passive components to solve the industry issues. You should do it. Yeah. And I was resistant because I was saying that it's completely out of economy because it's very difficult to get end users. But in 2017, I got an offer from Dean of Technical University of Brno at that time, and he said, if you organize this within first 2 weeks in September, we can offer you the facility of the university free of charge, because we have all staff already working, but we don't have students yet. So I said, okay, it's game changer. So we bring a new style of such conferences that is hosted by university, which is also a very nice thing because it's a better opportunity to really connect industry and the university in one conference, which is not purely scientific, but on the other hand, it's also not purely industrial. So it's merging both worlds together. And after the first conference is called PCNS, Passive Components Networking Symposium, then we had interest from other universities. So currently this is biannual event and it is changing location through the European universities that host such events.
Do you see how it influences the industry? Because it's really great that you bring together the industry and the university, and it's not only scientific thing, but it can bring all the different professionals that are connected to passive components together. And do you see how your efforts really make a difference in this area?
I think the key impact is in networking, to joining people together that would be very difficult to meet in different platforms. So scientists can meet industry, and from the industry we have also agencies that are joining us, also some media or other experts, and they can talk. That's why this conference is called Networking Symposium, as this is really the main mission is to meet. Yeah? And it's difficult to quantify outcome of such conferences. That is difficult to justify sometimes why to go to such conference, what is the real outcome. But during the years, we see how beneficial it is, because you have some talk that you consider unimportant. You just talk during the coffee break about something, and in 2 years you have, oh, this is the opportunity. I talked 2 years ago about the same thing at that conference. Yeah, where is the contact? I will try to call him. Yeah.
Yeah.
So it's very difficult to count the outcome, but we see this and we feel this, how this is important.
Yeah, I'm pretty sure that there are quite some collaboration between universities and industry happened. I'm pretty sure about that because it's a really great way to connect when you are doing it offline, especially. I think it's very important.
During COVID time, we had a hybrid event. It was 2021, so we could meet personally, but there were still some limitations. So we carried a hybrid way. But 2023, we completely switched back to live event, no hybrid. The interaction was not comparable to the live. Yeah. We had some virtual speakers, but they do not have the interaction with audience. We had some discussion, but also the person who is asking the question is not on the topic such as the live. So really strictly we limited the conference to live event.
Yeah, I agree. I mean, you can really feel the difference between your interaction online and offline. I agree completely. So the
Yeah.
next conference will be next year, right?
Will be next year, and it will be in Spain. The last one was in Denmark, and the next one is the organization is under discussion with Spanish university, and it will be announced in autumn.
Nice. I mean, Spain is a great location, I guess.
Yeah, hopefully it will not be too hot in September, because in Denmark we were afraid we are changing the location north and south and east and west, and in Denmark was it may be too cold already in September, but actually it was already hot in Denmark in September. So hopefully Spain will be fine.
Yeah, let's hope so. Let's hope so. But yeah, in general, you work with universities a lot. Especially, you mentioned the Brno University of Technology, basically your alma mater. Let's talk a little bit about collaboration with universities. Because when I talk with industry experts, often they mention that it's quite difficult to collaborate with academia because basically you have different goals. Academia they have their own goals, and the industry, they have their own goals, and it's very difficult just to come together and find the common ground. But how easy do you find to collaborate with universities? What are the challenges that your organization faces?
Working with universities, you have to understand the goals of the university and how university is working. It's completely different missions compared to the industry. So when you recognize it and accept, you can work together because your expectations are realistic. In past, I worked more with Brno University of Technology. These days, I work more with Katrin. This is the technology center of University of Palacky in Olomouc, and they are nanotechnology experts. They develop materials, and I'm trying to add here the expertise from capacitors. And each teams are little different, but I would say. But the essential thing is that university goal many times is high quality publication in impacted magazine, and then based on this to offer results to the industry. But here is a big gap between what industry can accept and the output of the university, because if we take some case study, university will develop new material and will publish it and will be great features, etc. But then when you start to talk about real output, you may find out that they produced a couple of grams or 10 grams of the material where they demonstrated that it's working and everything is valid, etc. But then when they go to the industry, you have R&D from a company, and they ask, okay, can you supply us with some material? And the R&D may have some pre-production capabilities, their own laboratories. But when they find out that the output is just few grams, they still cannot work with that. So they say, okay, but we need half of kilogram of such material. And this is big challenge of the university, because many times they will find out that scalability is an issue because they used some method, I don't know, sonification, which is not possible to use in mass scale. So they have to start from the scratch many times to be able to offer the scalability of their research. And that's an issue because the university do not have such strong motivation to do that, because all the research was already published. They got the main recognition for this, and suddenly this phase cost a lot of money and time, and they do not have such strong motivation to move on and start collaboration with the industry.
So how do you think it is possible to overcome these challenges? I don't know, I have a feeling that maybe it's even about having another organization, another party somewhere in between that will help to get what the university get in their lab to scale it and to help the industry scale it. Like, how do you think this challenge of different goals might be overcome?
Yeah, I agree with you. And this is a big point of many university. The important step is to have very strong and capable transfer office, yeah, with leading capable managers, because many times, even from in our case EU structures, the projects are pushed to have some spin-off, new startups, etc. But in fact, you are pushing the good researchers to become also good managers. Yeah, and working with administration things, etc. And it's not always the case that a good researcher would be also a good manager, and he may not be even interested to move because his enjoy is research, not managing the company. Yeah, so why to trying to spend effort on making good researcher also good manager? And here would be the role of transfer office, not in the way that transfer office would do everything, but the transfer office should help the researcher to find the right, very capable manager in the field of the interest and the scope of the research that can be really transferred to someone who would be eager to move this to the real industry and would have appropriate management, organization, financial skills.
But how often do you see really strong technology transfer offices in universities?
Very seldom. Time to time it happens, but many times you see this as a really weak spot of the universities, that they come with nice ideas, but they do not have the experience and or market insight or anything like this to really move this into something real, or adjust this to bring new value to the industrial market.
Yeah. As we're talking about bottlenecks and challenges in commercialization of university research, are there any other challenges that you think are also very important to overcome?
For universities, their main function should be the education, or must be the education of new generation. But this is linked to the whole education system in the country, especially in technical subjects. We see a really drop of interest to study subjects like physics, technical, electrotechnology, because the younger generation, they consider this subject as too difficult, and in social environment, they do not feel appropriate motivation to become an engineer, to get to be valued after completion of such study, which is pity, and with really challenge to start really with smaller children or already on grammar school, to really show them the attractiveness of technical subjects, including women, for example. I also partially trying to do something. I have a foundation to support children with microbit, with working with microcomputers that really attract people, young students, and it's unbelievable in like 6-7 class how they can work with that. And in many cases, I would say girls are more more capable than boys at that time, and it's pity they lose really the interest to move on to study technology. And this is the challenge for the university to pick up and start to working with high schools and even the grammar schools to really bring projects that would be attractive for students to come to study to the university. Yeah? What we see as like successful models are, for example, that students teach students. So students from the university goes to high school classes or having projects together, that the high school students can already work in university labs on some topic under supervision of students, PhD students of the university, or even the professors there. And but the same step down, like the high school students would go to the grammar school to help them, to show them what is capable on technical topic. But in general, it's challenge for us these days to really keep interest for technical subjects.
I know that the European Commission, the European Union, really sees a big danger in this, because people are losing interest, students are losing interest in these topics. There are less students, and of course, there are less capable experts for the industry in the future, and that means that we will lose this leading position in advanced materials, in materials in general, in the world, and the European companies will be losing it. But I think it is also related to this AI and in general software development industry. It's growing, it's bigger, and it's so much easier to get into this industry. And I guess that people just see these opportunities, and they don't want to spend too much time.
Yeah, but we need someone who would do the design of the hardware.
Exactly. I mean, we still live in the physical world.
Yeah, yeah. So we need some better recognition of society to these hardware engineers as a valuable jobs, as a motivation for people to go inside of the physics and mathematics, that it worth to get some knowledge.
How do you think the government can help with this?
I think the government is really trying to help. I think across Europe. I know the European environment and also Czech environment, and there are possibilities with different structures and supports to get projects. But always there is some competition. There are some rules, and this support is not free. Sometimes. It requires a lot of administration, but I see improvements. I must say the target is really to make this as simple as possible, not to overload with bureaucracy. Not always successful, but at least the projects are there. You can get interesting grants from the local nationality programs. You can try to get support from European projects like Horizon 2020 for specific areas. You can get support from space industry, from European Space Agency programs. So depending on the subject of the research. So for in general, I would say for these technical topics, we have in general good support and good capabilities. So if your project is high quality, you have a chance to get financial support from the government or EU. The worst situation is for humanitic subjects, which is more difficult to measure the real impact and get some financial outcome of the research. They are in worse situation. But as I said, for technical subjects and cooperation with the industry, you can find the resources.
Also, I know that government and specifically the Czech government supports also universities. I just remember when we visited the Brno University of Technology, when we worked together with you and the team of this university, we saw a lot of new equipment.
Yes, you can see a lot of very unique equipment. And we have more technology centers in the Czech Republic. It's not only Brno CETEC. There is RISE Technical Center in Pilsen and also in Olomouc. The nice thing is that each of them are a little bit different focused, which is quite nice. That is also tuned to support the local industry. For example, in Pilsen, they have lab that can test effectively very high voltages, very high power. This is linked with the Skoda transportation of high power meets requirements. At the same time, they work on smart textile, something from different world. Brno Technology, they have excellent semiconductor experiment equipment for supporting companies like OnSemi with development of new semiconductor structures, ceramic structures. This is where I was based in the projects that we had together. Was development of ceramic dielectric materials. In Olomouc, they are based on nanochemical structures. They can do a lot of with bio things, and the work that we are working on is with graphene for supercapacitors. So there are different teams with specific capability and knowledge, which is great. So equipment-wise, I think we are in very good shape. What is the real challenge is about the employees and professors and people that are working in these institutes, and how to make these centers economically viable. Because of course, amortization of such equipment is very high, and partially. These centers live with support from the government on the government projects, then the concrete research projects, and also from the industry cooperation for failure analysis, etc. Yeah. But the difference to the industry is that industry is not basically interested most of the case in basic research. They are more pragmatic oriented naturally, and the philosophy what we hear with many industrial companies, and it has its logic, is tell me how much it cost, then when this will be ready, and what will be return, and then I will decide if I give you money or not. Yeah, it's very pragmatic approach, but it's not possible to do basic research with this because you don't know the outcome. You don't know the market to quantify the outcome and say what is the potential return, and the risk of return is quite high. Yeah. And this was the special case for passive components because. Passive components for decades, it has been considered as something easy, not so interesting for engineers. Yeah? That in capacitors you have one metal, insulator material, and the metal. That's all. Yeah. The world labs were more focused on semiconductors. Today we are in situation where on semiconductors we are counting electrons and holes, but basic understanding of passive component is on a very basic level in many cases, due to the fact that this research was left on industry without the support from the government that would support the basic research. But I must say, I see the positive trend. It's now changing with the new capabilities of nanomaterials and nano engineering. There is an interesting field of energy storage, energy transfer, and this nano engineering can really bring capability of development of completely new generation of materials that can move significantly the passive components to new level. And when I say the example with the capacitor as a metal insulator metal, I use this when I'm talking to students and university, trying to motivate them why to study. I said, you consider this is simple structure, metal insulator metal, but you consider that most of the metals has an oxide layer, natural oxide on it, that is semiconductor. So in the real case, you have metal, semiconductor, insulator, semiconductor, metal, and this is even more complex system than easy semiconductor. How to move with the electrical potential, how to adjust everything, and this is really a challenge to understand the physics of this. So it's not so simple component.
Yeah, that's really interesting. Question that I have also is about international cooperation. For the European universities in general and also the Czech universities, do you see a lot of international cooperation happening inside the academia world, but also with other industrial partners from the outside of Europe?
I think as always, there's always a room for improvement. Yeah, especially cooperation between universities and industry. But the main issue is what we already discussed. There is a big gap and death valley between the outcome of the university and what can be taken as a input for R&D on the industry. That is many times very difficult to overcome this challenge and need some effort and support from, as we mentioned, transfer offices or startups to really go over this. If we talk about cooperation of universities and consortium in Europe, we see a number of programs like this Horizon 2020 that is helping cooperation, and I see it's effective joining teams together. And again, I would say the networking is one of the key outcome of this. Not only the project itself, but that you start to find new partners, and it always bring something new innovation or new ideas together. So that's great, and I think it's working. We can discuss how bureaucracy is there, need for administration to pass all these questionnaires, and if this is too much overstressing due to administration. It's always difficult because many times you have an evaluation team who is not expert in your particular topic, so they may not always understand the topic so well as the researchers. So that's the matter of misunderstandings and sometimes difficulty to meet the objectives. On the other hand, many times from the university, you don't have such a strong push on time. But the industrial way, they want to monetize the thing, so they see a horizon of 2-3 years to see some return. While universities, they do not have such deadline, and as a sometimes I use the phrase that deadline is the best muse. Yeah, it's working well when you have the deadline and you have to meet something. You really start working to on this more intensively. So it's also useful to have some deadlines, which is difficult for some researchers to hear because they don't want to do the research under the stress. But the other hand, from the industrial economic point of view, you cannot do something just to enjoy for 10 years to do the research without the real output.
Yeah, that's true. That's true. But what about also, you mentioned that within Europe, collaboration between universities is working really well. But what about other countries as well? Do you collaborate a lot with maybe Asian universities, American universities?
I would not say a lot, but there are projects that are cross continents as well. Sometimes it's difficult due to geopolitical reasons, especially now, and it's also changing because we see some limitation of globalization now, and this is change over the past decade, and we see decoupling of supply chain between US and China, etc., and the war things in the globe that really impact the complete supply chain, availability of materials. So they are bringing new topics and some cooperation becoming more difficult. Then the other issue that we have not touched is the IP rights. Yeah. Mm-hmm. So if there is a collaboration, who will own the IP? Yeah, and this is sometimes really challenging, and it has to be well defined already at the beginning of the project. And if it is between industry and university, this may be also a challenge because then the industry, big company, may have an issue if any IP would stay with the university. They want to keep the IP for themselves, and then when is the discussion like, okay, we will do something together and we will share the IP 50-50, and then the industry partner may say, no, it's not my interest. It's rather I would spend only my own money in something to get 100% control over the IP.
Yeah, that's true. That's not that easy, but I find it more easy with the European, like smaller universities that are more like applied and they're more industry oriented. Mm-hmm. But with top universities, it's always a huge challenge. But also, you mentioned that for many professors and university researchers, they don't want to manage anything. They just want to do their research, but sometimes we have cases when the university researcher wants to create their own company. They want to go with a spin-off. When is it the right time, do you think, for the university researcher to do that?
This is a good question. It can be very specific per the case, because the question is about the real model of the new company. Is it viable, or do we want to create what company we want to create? Is it for short term or longer term? So should it create some value and sell everything and then close the company, or should be the company that will continuously create some value? That is one of the basic questions for everyone to ask. And then do we know the market? And this particular question I see is a weak point of a lot of researchers, because they do not have all the information about the market. They do not have the market strategy, market evaluation, market survey, etc., to have realistic view on the chance of utilization of outcome of their research. What is the potential application? What will be the potential market? How much volume has a chance to succeed? So this is usually the weak point. Mm-hmm. And without that, this is like a blind chicken coming to the market. Yeah, and this is the reason why many spin-offs also then are not successful. Yeah, but back to your question: when is the good time? When you have a product that gets interest from the customer, from the specific user. When you have a user that says, I want to use what you are doing. Because to really start the business, you want to really have some cooperation partner that would be your angel company for the first years to survive. Because you don't have to create a mass manufacturing facility in first year. You have to prove the concept that it can be used in the industry. And if you have the angel company that help you, that they will buy the product in a relatively small quantity, but will pay your expenses, yeah, that is a good start.
Yeah. Do you think that these technology transfer offices can be of help to university researchers? Like, can they help at least with some data for the market or like some information to start?
Absolutely. But the rule of the transfer offices is not to gather the data, it's to find the right partners, like to help to find the angels, the angel managers and angel companies that would be interested in the research and understand the potential of the research as well. So they can have the better insight of the market, and they can come with some realistic figures about the capability and usability of the outcome of the research in practice.
Now, here I have a question that is connected to the technology transfer offices. For example, there is this spin-off that wants to be like a separate business, meaning that the university researcher is leaving the university basically. They will not be that involved anymore in work connected to the university, and the technology transfer office should they should help to this spin-off to this potential new business. But what is it in there for the university? Why should they invest their money to create this strong technology transfer office?
It's a good question, because the current main motivation for the university is to have publication in impacted magazines, and not so strong motivation to really use the outcome of the university in the industry. Question within university would be why to invest a lot of money to initiate the transfer office, and why to have very high level managers for appropriate salary and capability, and giving really the conditions to have the state-of-the-art experts that would help researchers of the university to move their outcome to the real product. So that's why I say it's happening very seldom that university put this as their goal, while their recognition is mainly by scientific papers and scientific outcome. And you can hear opinion like this is the main function of university. Main function of the university is to provide education and also have some scientific results. But use of the outcome to the industry is something that is not on the top of priority in many cases, unfortunately.
Yeah, but that's very interesting. I mean, it's like a huge challenge, and I think it gives lots of opportunities to find the solution to this challenge.
Absolutely, I can say this should be the know-how of the university.
Definitely. Yeah. Okay. That's very interesting, really. So you have already mentioned about these passive components and the future of passive components. You mentioned these nanomaterials that can be of use. Do you see any other interesting breakthroughs, interesting innovations happening in the industry?
There are a couple of we can call these mega trends in the electronic industry that drives the future development, and one of these are wearables, electronics that we can use as a smart textile, etc. Small, flexible items. The other mega trend is the electrification of transportation in general. The challenge there is, for example, in capacity field, is how to increase the energy density in the field of like 1000 volt devices, this is the really challenge. And if someone can bring with new dielectric material that can provide higher energy storage, but at 1000 volts. This could be used in a number of applications like generation of electricity, but also electric vehicles, etc. So this would be there is a huge demand for such thing as well. Then of course we have things around AI development, computing, processing technology, which are linked to the development of semiconductor devices. Particularly talking about the semiconductor devices, we see the move of processors to higher and higher frequencies with lower and lower voltage. And the challenge again for passives is to work with these frequencies. In fact, it means minimization of or parasitic or everything. And in medium and long term, what it means is we have to place passive components inside of the chip as integrated passive devices to minimize any connection there to really work directly on semiconductors. So we call about on the chip integrated passive devices. So definitely there is the other trend. Automotive, I already mentioned as a part of electrification of transportation. I think these are the main ones.
And you mentioned a little bit about AI. Like, how do you think AI can impact the future of passive component? How do you think AI can help overcome the challenges? Will it?
Indeed, AI is a strong tool that has impacted all our life and will be even more in future, even in near future. And as we can say about any strong tool and strong energy, is a good service, but a bad lord. Yeah, so as far as we use it and we utilize it as a tool, it's absolutely great tool. But if we leave it alone to control our life, that would be the danger. And if we talk specifically about impact of AI on my institute and on EPCI, it has very strong impact in two things. For me, is a great help and assistance when doing some articles. It's great to put text together and images together. But the important thing is that I know what I want to write. If I know what I want to write, I put right question, and I see 4 or 5 different answers from AI, and 3 of them are completely useless. Yeah, because when you understand it, say no, it's completely misleading. Then you recognize the right one, and then you change a couple of words, and you have perfect article how best you would say it, and it's tremendous help. It saves 80% of your work. So it's great tool. Similar things if you want to illustrate what you are saying with some image, it's also a great tool because you just describe and it will generate some image, and you have then featured image of the article. Absolutely great. But the thing is, you have to understand what you are doing. Then it's a great tool. If you don't, and you use just whatever the AI is output, then you can be completely misleading. That would not be helpful to anyone. On the other hand, the AI is destroying what I have built over the years in the thing that I build a knowledge-based block where there is a concentration of knowledge around passive components and a collection of news. Yeah? But such website is now taken over. The content is taken over by AI practically. So AI is taking content from my website and offering this as an answer to the questions to AI. But then there is no interaction with my page directly. So I have significant drop of impressions of visitors to my website directly because it's been served by AI. How I know this is that my Google search position is still increasing. Yeah, so I have significantly drop of individual visitors to my website, but on the other hand, I see improvement in Google search position of the phrase. It means that these pages are still used, but they are not so often. It has the impact, but I'm becoming more volunteer feeder of knowledge to AI.
Yeah.
Yeah. The business model that would be based on advertisement, for example, is in trouble because it's paid by number of impressions, and I would say the number of impressions compared to last year dropped by 2/3.
Oh my God,
Yeah,
that's a lot.
that's a lot, and this is based on the fact that this is a knowledge-based website because I do not sell anything. There is no distribution, etc. So people are going there to get knowledge, to get some news and knowledge, and this is the main function of AI as well. So this is exactly impacting the blog. On the other hand, I must say that I have a lot of supporters, and thanks to the sponsors and the members that understand and like what I'm doing. So significant income that help this institute running is not directly impacted by this because these are the people from the industry, and they understand and like what I'm doing with sharing of the knowledge. Because a couple of years ago, I had interesting discussion with hardware engineers of one big company, and I asked them what the tools you would need and knowledge you would need from passive components to make your job easier. Do you need some database, anything that would help you? And they said, honest answer. I say, yes, of course, honest answer. Honest answer is we have so many information, we have so many databases that we don't remember where is what and what is valuable. So actually the solution for engineers, like it or not, is Google search, which can be frustrating by someone who invests in knowledge, etc. But as I say, it's better to deal with the devil than to fight with it.
Yeah.
Yeah. So then I understood I have to change the approach to design engineers, that the target would be really to score high at Google search. So if someone plays their phrase, for example, leakage current of capacitor, then naturally the outcome with independent validated results would come first, and that's the target. And fortunately, I'm on the same page with number of companies that support me, saying we really like what you are doing, regardless your outcome and measurable is not so obvious, but we feel that's important that you do what you do.
Yeah.
And it's also a high motivation for me to work with people like this from the industry to really support the industry like that.
Yeah. Yeah, that's really great that they do understand the importance of what you're doing. And personally, I do believe that AI, of course, is a great assistant. But as you said, you need to know and you need to be an expert. Then you will get some outcome. I still think that people tend to go to people and tend to deal with people, and we want to work with people. We don't want to work with the machine. So the experts will be there for what you're doing, and just some other people that want some basic information, they will go to AI, because at least for now, AI cannot give you the depth of knowledge that the expert has.
Yeah, but we are not going to stop AI to move forward. So as I said before about Google search is also valid about AI. It's better to deal with it. So let's try to make this more accurate and better. Yeah, to give the right answers and right results. That's the thing that we have to do.
Okay, I think I have my last question to you about your plans for the future.
The plans for the future is continue what I'm doing, but on the other hand, I see what's going on as a challenges related to AI, how the things are changing. So I have to understand what to do best to support these tools and to support passive components industry the same way. And I'm going to continue with organizing networking event, a meeting with live people in Europe, in US as well, and also globally, and continue in the website. The website is a really the global one. The number of attendees is 30% US, 30% Europe, 30% Asia. So it's really the global impact with very equal share. So I'm going to continue with this, and side by when I have the opportunity to push some interesting technology, as I'm currently doing with a new generation for graphene supercapacitors with another higher level of energy density and power density. That's for me is a nice part of my job where I see the real outcome. That sometimes when you do in virtual environment, yeah, it's something that you cannot touch. Yeah, that's difficult. You create something virtual, and if you switch off your computer, where is the outcome? But when you can touch something, the real new generation of capacitor with higher energy density, etc., is something that you can touch. So I want to have also the balanced output of what I'm doing.
Yeah, so you have really excited plans for the future, and I wish you all the best. I'm sure that everything will be great, and what you're doing already and what you did in the past, it has a lot of impact for the industry, for the universities that you work with. Thank you so much for such a great interview. I learned a lot, and it was very interesting for me to talk to you.
You're most welcome. Thank you for your invitation. And also, I wish you success in what you are doing. You have a number of challenges ahead of you. I wish you all the patience and enjoy it, because you have to enjoy what you are doing, as you mentioned. So I wish you really enjoy these new challenges for you.
Thank you so much, Tom, and yeah, I wish you a great day. Thank you.
Yeah, likewise.